Okay, this is my temporary capture device until a more permanent solution can be thought of and implemented. The system works off of the buoyancy of the oil. It's made to work in a rough sea. It's made to work in an ever-changing sea. What we have here, floating apron with weights to keep it in a vertical axis. This would be a buoyant ring that would go in a circle or rectangle, and it would be the edges of this. It'd probably have to be several foot in diameter. There's guide cables here to this buoyant tie-off. I'll explain here in a second. The guide cables would have to be stretchable so that as the wind and the waves would come and happen, and if we had a horrible storm or anything would happen, that it wouldn't bust anything off. I want to start by saying the benefits of this is it would work in any situation, not just this one, regardless of the sea bottom or the depth. It works off of an open system, open top containment. There are vent pipes the whole way down. We have a vent pipe to equalize internal and external pressures to prevent pipe rupturing. And oil wants to go up, it's not going to turn around and come back down this. It may to prevent a blowout, but under normal operating it will not. This would be just your standard large plastic flexible pipe, like a black pipe. The quantity of these vertical towers would be determined by the flow rate required and the efficiencies of pipe diameter versus cost. At each joint of the pipe, there's two steel cables that go the whole way parallel to each column of pipe, and there would be an oval-shaped retaining ring that would go in the ridges of the pipe. Here you see the ridges of the pipe, and these retaining rings would slide in before and after each joint and hook up to the steel wires. The purpose of them is to keep joint integrity so that things don't be coming apart whenever this whole thing shifts. The whole idea is to keep forces equal so that there's nothing to burst, nothing to explode or rupture. Every so often, also to be determined by the weight of the pipe and the metal and the wire used, you would have buoyant tie-offs, and these buoyant tie-offs would be hooked up to a deck plate, or an attachment plate I should say, and their job is only to support the weight down to the next buoyant tie-off. Here we see two in a row. Let's see. The buoyant weight canceling devices to be at determined distances to avoid excess strain anywhere, and they would vary in their buoyant force depending on the depth. As the oil comes out, this is an open system. Like I said, oil always wants to rise to the top. It's always buoyant unless we put dispersants in it. So if we had a weighted down funnel, so to speak, that allowed equal pressure, it could be made out of very cheap materials because the pressure difference is the same. If there's 5,000 pounds here, there's 5,000 pounds here. As long as it was not a hollow wall, it wouldn't crush. Similar to an air compressor tank, if it held 200 pounds at sea level and at an equal rate you increased the internal to 1,200 pounds and external to 1,000 pounds, there's still a 200 pound differential. So the air compressor tank would not burst even with 1,200 pounds. But if you removed the external 1,000 pounds, then the tank would burst. So I understand that the oil is coming out with a lot of pressure. Pressure is relieved by being into an open atmosphere, then reclaimed, not under vacuum, not under anything else, and it'll work like a chimney. A chimney is not pumped, the chimney is not under pressure, it's open at the bottom and open at the top, and the buoyant force of the oil will draw it up. Then you can bring in your tankers, pump it out of here as needed. You have your usable oil. Yeah, you have to drain some water off, but it's better than having oil all through the ocean until you come up with a more permanent way of dealing with this. All you would need some plastic sheathing, obviously a lot of it, some float devices, some weights. It could be a cinder block. Think simple here. That's not a big deal, and this could happen a lot quicker. I've seen what you're doing on the internet. I'm very aware of how much brain power is into this. I don't claim to have supreme brain power on this. It's just we need a flexible system that'll work for multiple situations, and we need one that can be done quickly, affordably, and efficiently. And this is very quick, affordable, and efficient. Again, if this tank is kept separate, if this is all separate with just an expandable material, just for guidance, it would be able to withstand fairly severe storms and some major changes in atmosphere pressure, changes in sea level, as in tides or currents or hurricanes. Again, it wouldn't be 100% containment, but it would contain and it would entrap a very high percentage.